Section C6, circular motion. There is acceleration because velocity is a vector, and if you keep the same speed, the magnitude, but you change the direction, you have acceleration. So we're going to do that. Looking at a case here where we're going around a circle, and say we're at this point, a little particle or a mass going around a circle in a radius r. You see, if it were to be going at the straight, it would wind up here, but it doesn't. It winds up there. So what's happening here is that it's like you're falling down. It's like you're falling. So let's say this is little h here. You fell down. This is r, radius of the circle, and you're going at velocity v. So this distance, say is time t. We would go up here, but in that time we're going to fall down here. Now, as you make this angle smaller and smaller, this distance will agree with the distance along the arc. As you shrink things down and get smaller and smaller, then you would have a case where, like here, see a smaller, see it has a smaller case and agreeing more. So here what we're going to do is Pythagorean theorem on the this big triangle, little r. Let's say here, since the book I used capital R to emphasize that this is a big radius, let me just use capital R here. Capital R plus h is your hypotenuse, and you square it, and that's equal to r squared plus v squared t squared. Now this is r squared plus 2rh plus h squared equals r squared plus v squared t squared. These cancel, and here, since this r is very, very big and this h is very, very small, that we can neglect this. In fact, as you get smaller and smaller with the angle, this will vanish. It'll go away, with calculus, ideas, taking limits. So therefore, I'm going to write 2rh is v squared times t squared, and that means h is equal to 1 over 2r, v squared times t squared. And if I group these, I'll have 1/2 v squared over r times t squared, and compare that with my acceleration kind of problem. 1/2 at squared. You have the 1/2 there, you have the t squared, and see the acceleration is given by the v squared over r. Very important formula. Can you believe that?